Okay, good afternoon. Hopefully this video will help you in simplifying exponential expressions. So let's begin. There are more than one way. There is more than one way to simplify expressions. I will go over with you different possible ways, and I will make my recommendation as to which ways I feel work best. For this one, there's two ways that we could do this. The first way is whenever you're multiplying numbers or variables that have the same base, you would add their exponents. So here we could say that, oh geez. So here we could say that this becomes a to the negative fifth plus negative 7 plus 6, which is a to the negative sixth power. Now, since they want it to be only positive exponents, a to the sixth power equals 1 over a to the sixth power, a to the negative sixth power. Now, I prefer to approach this problem a little bit differently. I prefer to immediately set up this problem, first of all, as a fraction, and then to identify any numbers that have a negative exponent, and I'm going to physically move them to the other side of the fraction bar. So both of these are on the top, they go down to the bottom. So this becomes a to the sixth power over a to the fifth power times a to the seventh power. Remember, when you move a negative exponent to the other side of the fraction bar, it then becomes a positive exponent. Now this becomes a to the sixth power over a to the 12th power. And then again, there's two ways that we could do this. If we use subtraction, because division of two numbers with the same base, we subtract the exponents. 6 minus 12 equals negative 6. So this would become a to the negative 6th, which is 1 over a to the 6th. But I prefer to look at it this way. There are 12 a's on the bottom and 6 on top. Therefore, there are more a's on the bottom, in fact, 6 more. So it's a to the 6th on the bottom. Since we're left with nothing on top, there's always that 1, and then hence we get the same answer, 1 over a to the positive 6th. For this one, again, we're already set up with a fraction, which is nice here, a fraction bar. So I'm going to circle my negative exponents, and I'm going to rewrite this with those switched. So c to the sixth, the top one isn't going anywhere, but c to the negative 6 down here is going to go up top and going to become c to the positive 6. Now, that leaves nothing left down below, but we're going to add c to the negative third. We're going to bring it down, which means it becomes c to the positive third underneath. Then we have c to the 12th over c to the third, which, if we use subtraction, 12 minus 3 is 9, or we have 12 on top and 3 c's on the bottom. Therefore, we have 9 more on top, and it's a, oh, I don't know why I said a. The last one was a. It's c to the 9th. Okay. Once again, actually, this is a time right now with the starred question where you can pause the video and try this one. When you unpause, I will go over the answer. Okay, so hopefully what you did was you circled your g to the negative 4th and your g to the negative 8th. You rewrote this. The g to the 3rd stays exactly where it is, but g to the negative 8th on the bottom is coming up to join it positive. And on the bottom, we're left with nobody, but g to the negative 4th is going to be coming down, and it's going to become positive. That's going to become g to the 11th over g to the 4th, which equals g to the 7th. Okay, please check to make sure that that's the answer that you got. Okay, now This is one where students right away, they want to say, oh, look, we've got a -1 and this is a +1, so cancel those out. This equals n to the second. No, do not do that. Don't mess around. Negatives can sometimes act funny. So I want you to keep what we've been doing. Circle any negative exponents. Bring them to the other side. That leaves us with n to the second power on top. We have n on the bottom, and now we're adding n to the negative first power from the top, so it's going to be n to the first. Well, that n has an exponent of 2, so this is n to the second over n to the second, which equals n to the 0, which any non-zero number to the 0 power equals 1. So we're going to assume that n is not 0, and therefore our answer is 1. Okay? This one, again, we've got these smaller exponents, but this is a 1 and this is a -1, so this is going to go down. That leaves us with r left on top. On the bottom, we have r to the 9th, and we're adding r to the positive first now, which gives us r over r to the 10th, which gives us 1 over r to the 9th. Now, you might have also seen when we got to this part right here that now that we have all these positive exponents, these two will cancel out and leave us with 1 over r to the 9th. But if you didn't see that, there's no problem. It was just a matter of seconds for us to finish this problem off. Okay, this one right here, we're working with big numbers. Big numbers don't get scary. We're just going to put this over 1. We're going to circle all of these. Every single one of these is going to be moving to the other side to become positive. Nobody's left on top, so we're going to put 1. On the bottom, we have the 1, but so many things are being added that I just had to make sure that that was what it was. So m to the first is coming down, m to the 95th, and m to the 98th. Well, now we're going to add those all together, and we wind up getting m to the 194th. Big guy, but don't be scared of those big numbers. Okay, this is one where I'd like you to try it on your own right now. So pause the video, and when you are finished, unpause, and I will show you the answer. Okay, hopefully the first thing that you did was circle the negatives. You can also, if you want, t to the 0 power, anything to the 0 power equals 1, so it's useless, it's pointless, we don't need it. So that's going to leave us with t to the 0, but that's not, we don't need that. So t to the 44th is coming up, t to the 1st is going down. That leaves us with 43 more on top than on the bottom, so it's t to the 43rd power. All right, this one, we've got this negative, it's going to go up. That's going to leave us with nothing on the bottom. That's okay, that's a 1. So we've got p times p times p times p to the 96 is coming on up. Like I said, nothing on the bottom, so it's really 1. That's going to give us 99 p's, p to the 99th, over 1, which is just p to the 99th. Hopefully you're starting to get the swing of this, and as you can see, as things are getting more and more complicated, they're not really more and more complicated. It's all the same thing. We're doing the exact same thing. We're just taking all of our negative exponents. They're all going to switch. So m to the 6th is staying on top. Joining it is going to be m to the 3rd from the bottom. On the bottom, there's nobody that was left over, so joining nobody, or 1, will be m to the 88th and m to the 1st. Now I'm going to simplify the top, m to the 9th, simplify the bottom, m to the 89th, and then I prefer to look at this as if I've got 9 m's on top and 89 on the bottom, that leaves me with 80 more on the bottom than on the top, so m to the 80th and 1 on top. If you use subtraction, remember, if you use subtraction, your answer, the exponent, whatever you get, will always be on the top. So if you decide to say m to the 9th minus 89 equals m to the negative 80th, that goes on top. M to the negative 80th over 1 equals 1 over m to the positive 80th. Okay, so you wind up getting the same answer as long as you understand that you have to do the same to the, whenever you subtract using division, if you're going to use that rule, that your answer goes on top. Okay, now we are looking more complex here. We're like, oh gosh, we've got a lot to do. It's not that much. The first thing, r to the 0 equals 1. We don't need it. S to the 0 equals 1. We don't need it. Now, we're just going to identify just the r to the negative 5th. I would circle it, but then I wouldn't be able to read anything else. That's going to have to change spots. So, on top, I've got q times r times s to the 5th, and joining it will be this r to the negative 5th, but it's going to be positive when it goes up. On the bottom, I have q times s to the 7th. Now I'm going to combine q, r, s. Q times q is q squared. R times r to the 5th is r to the 6th, and s to the 5th over q times s to the 7th. Again, I'm going to show you my way first. I prefer to look at this as each individual letter, who has more, how many more. So for the q's, the top has more, one more. So the top is going to keep one q. For the r's, the top has 6, the bottom has none, so that means the top has 6 and 6 more. And then for the s's, the bottom has more, 2 more, so s to the 2nd on the bottom, and that's your answer. If you use subtraction, everything would be exactly the same. 2 minus 1 is 1. For the r's, there's nothing to subtract, so it's r to the 6th. And 5 minus 7 is negative 2, so it'd be s to the negative 2nd. Once you did that, you'd have to then take that and put it on the bottom, and you get q r to the 6th over s squared. Same exact thing. All right, this one, let me see, we've got a few more, but I don't think we need to do all of these. I think we're going to stop after this one. I would like you to do this one on your own. When you finish, unpause, and I will go over the answer with you. All right, so hopefully what you did was you identified all of the negatives. Okay, those are all of the exponents that have to go to the other side of the fraction bar and become positive. So a to the 6th, that one is staying. That one is going, so we're going to ignore it. That one's going. A to the 8th, that one gets to stay. B gets to stay. C to the negative 9th is going away, but joining it is this a to the negative 1st is coming up to become positive. Now on the bottom, we have b to the 9th. C to the 0 we don't need. Remember, we can cross that off because that's by. Joining all of my poor little lonely b to the 9th is going to be this b to the negative 4th is going to come down to become positive. C to the negative 7th is going to come down to become positive. And c to the negative 9th is going to come down to become positive. Now we're going to combine a to the 6th, a to the 8th, and a makes a to the 15th times b over, there's no a's on the bottom, so we've got b to the 9th, b to the 4th, that makes b to the 13th times c to the 16th. And then the only thing we're really simplifying here is there's no a's to simplify. There's one b on top and 13 on the bottom. That leaves 12 more on the bottom. And there's no c's to simplify. And so that should be your answer. And that's hopefully what you've got. Okay? Please let me know if you have any questions after this. I am available in AA. But hopefully this cleared some things up for you.